Howdy, AP PreCal. It is Miss Kosh. I realized when I wrote part of the test or the quiz with calculator that some of my students had good calculator skills and some didn't. And so I made this practice. I have 3 different problems. They're rational functions that are really gross, but they would expect you'd be expected to know how to do these with calculator, okay? So I wanted to work through these. I may scan it and make it my answer key. I did manage to find, somehow there was a TI in my desk drawer, and I had found new batteries, and here's a CASIO, which I prefer. So I'll try and show you some of the CASIO things, and we'll see how far we make it. I think these questions that I wrote are more difficult than what AP is going to be asking of you, but if you can do this, you can do anything. So let me show you how I think through these problems. Okay, so to begin with, find all x-intercepts or show mathematically why there aren't any. So what I would do, and to save time, I already typed everything in. So you may notice they're all there, but it's not selected on this calculator. I turned it off and over here. So in order to turn on this first graph, let's see, where are we? I have to come here and hit select, and then when that equal sign is highlighted, then that tells me that I'm going to actually graph it. Same thing over here with the TI. So I can hit enter on that. So with the TI, I hit the graph button. With the CASIO, I can just hit enter, and then it'll graph, or I could hit that where it says draw. Okay, so on these, what I forgot to tell you is that I like to typically go shift window and then do a standard window for some of these rational functions. It was previously set maybe on the trig. Nope, not on the trig, on the initial. Okay. But it's a decent window to start from, and I think this is what the window that the TI started from. I didn't have to tell it that, but anyway, like when you looked at that one and you looked at this initial one, you couldn't see the whole graph here. But we can just always go window standard, gives me -10 to +10. Draw that. Okay, and now those two equations match. Well, it doesn't look like I have any zeros, but I can G-solve and find roots. And here I would do second calc, it gives me, and then I can look for zeros. But with the TI, it requires me to tell it where to look. This one is saying none, but what I would do is I mean, I know there's none. I'm going to tell you how I know in just a minute. But I would say, well, maybe there's some through here. So I'd say left bound. I have to tell it where to look. Tell it left bound and then scroll over. I think I could even just say like -1 would be a right bound. That might be easy. And then I take a guess, hit enter. So the CASIO gets a little faster, no sign change. I knew that exit. I knew that there wasn't a zero. Hit exit. Here's the exit button. Okay. So here are the graphs. Let's look at why there was no zero. If I take the x squared plus 6x, and I decide I'm going to set it equal to 0, so I'm going to subtract 11. I just saved a step. Pretend I'd set that equal to 0, then I subtract 11. I'm going to complete the square because my x squared has just a coefficient of 1, and my x value has an even number, which makes completing the square, in my opinion, ridiculously easy. And so this equals -2. Well, as soon as I try and do the cheer, square root, plus minus, I get that x plus 3 is equal to plus or minus, well, negative. I was going to put an I, and I didn't write it. Okay. But basically, I have x is equal to -3 plus or minus I root 2. There are no real zeros, so it's not going to have any x-intercepts. So you would tell me something like that. Okay, next one. Find the equation of all asymptotes. Well, you may notice both of these graphs appear to have a vertical asymptote. It's a little tricky to tell from the graph what that equation is, but you should know enough to know that my vertical asymptotes come from setting the denominator equal to 0. So when 3x minus 2 equals 0, we have x equals add 2 divided by 3. So x equals 2/3 is a vertical asymptote. And then we see that this is top heavy. So I'm going to need to do synthetic division because it's easier. Oh, no. Well, can I show you something? If I use this, I'm dividing, my 0 here would be 2/3. When I do synthetic division with this, I've avoided this in all of my classes, but I want to show you what happens. It's 1 times 2/3. Oh, well, see, it just gets gross. This is 18/3 plus 2/3 is 20/3. When I multiply back, I get 40/9. But you know what? I don't care about that part because but this won't exactly be my slant asymptote because Well, okay, what's a better way to describe this? We really needed to do long division on that one. And let me see if I can connect the two in just a second. So if I take x squared plus 6x plus 11, and I do long division with 3x minus 2, then I get x squared, that gives me 1/3 x, multiply back, and I get x squared minus 2/3 x, and then when I subtract, I lied. Subtract. This is 18 over 3 plus 2 over 3. It was 20 over 3x. And then when I divide that, I get this. We saw, this is annoying. 20 over 3x divided by 3x means that I have 20 over 3x times 1 over 3x. The x's will cancel, and this gives me 20 over 9. I can keep going, but I don't need to find the slant asymptote. Oh, y'all, that was annoying. What happened, though, is that this one, we'd have to factor out a 3 from here to get the actual thing. So if I factor out a 3, because what's a better way to describe this? Basically what's happening, okay, here's what I showed my IB kids yesterday. If say I have 2x minus 1 and I multiply it by x squared plus, let's just do 4x plus 4. Okay, so if I want to do, this multiplies back to giving me 2x cubed plus, this is 8x, so plus 7x squared. Here's x, it's going to give me 8x. This is going to give me minus 4, so plus 4x minus 4. I think that I did that correctly. If I do synthetic division with this 2, 7, 4, negative 4, and I do a 1/2 right here. When I multiply, I get 2, all right, not multiply, what am I saying? When I do synthetic division, bring down the 2, multiply by 1/2, I get 1. This gives me 8. Half of that is 4. This 4 plus 4 is 8. Half of 8 is positive 4. This gives me a 0. So what I just found is x minus 1/2 times 2x squared plus 8x plus 8. Notice this is not what I started with, but if I factor out a 2 from here and multiply it through this one, it gives me back to where I started. So that's why I hesitate to do synthetic division here. So I shouldn't have ever even bothered. That was a whole lot of, sorry, you can ignore a lot of what I just said, but the final answer on this one became y is equal to 1/3 x plus 20 over 9. And I want to grab a calculator and see if that makes sense to what I have here. Exit. I have number 2 and number 3 already typed in. We're going to leave those alone. Okay, so it's 1/3 x, this is the x button, I've had kids miss that before, plus 20 over 9. I love that fraction button. And I draw, so here's that graph, and here comes that asymptote. And so that definitely seems to make sense. So will the calculator give that to me? No, but I could use the calculator to check. Okay, let's finish the calculator stuff. Okay, so, you know what, we don't need that anymore. Delete, there you go. Okay, so find all the values. Let me turn this one back on. Find all the values where f of x equals 1. So here's my graph. I lied, that was -1. Okay, so what I can do with this graph, I can do G-solve and come over and do an x-cal. And so they're like, well, when y is equal to -1, what is my x value? And so I find that x is approximately -7.8541. Get used to doing 4 decimal places is what my colleague said. Even though they expect 3, if you give it a 4, you won't be wrong. Over here, the other option would be to come back here and just say y equals, nope, -1. I was looking at the next problem. I'm sorry, it's this one right here. And then I can graph those and find that, oh, so notice that was probably a good idea, because now when I do G-solve intersect, I have an answer here, and I have an answer here. So I think I'd already had the first one. And the other one was, I did that on purpose to give multiple answers, and then I forgot when I started the video. And that would round to here. Okay, on the TI, second calc, can I find? It doesn't appear, maybe a value, will that work? I don't know, it'll let me do the x values. So if I said x equals 3, it'll give me this. So f of 3 right here is about 5.4286, which I got from here, but it won't let me do the other way around. So with this one, I would have to do, I would go back to YCal, to y equals. I'm sorry, this is a little humbling for me because I used to be an expert at TI, but we've gotten so into the Casio that I'm a little less amazing. Okay, so second calc, I can find the number 5 is the intersection, but they want me to, okay, first curve, second curve, and then I take a guess, and so this one gave me that equation. I have to, it doesn't let me scroll over to find other things, but I can do second calc, do the number 5 is my intersection. First curve, yes. Second curve, hit enter. And then I'm going to have to come over here. Do you see why I say the Casio is a little easier to work with? And there, that should match the number I already have. Can you read that? Oh my goodness. Can you see that screen? Oh, I didn't know you couldn't see the screen. Can you see this screen? I think you can. Well, I apologize. Hopefully that talking through it made a difference. Practice with your calculator. Okay, then I said find the range. I can get rid of this. I don't need that anymore. Or I could just turn it off, but it's gone. So what I'm going to do to find the range, notice there's this big gap between here and here. I can do G-solve max. And it finds this is the largest Y value in this area. And so I think this is right. I don't know that they're going to ask that question. I just wanted to have you practice finding, I just wanted to talk about all the calculator things I thought you should know. So it looks like negative infinity to the Y value of negative 0.1755. And then we can pick it up again and do G solve minimum over here. Oh, that's interesting. Okay, I couldn't tell that it was there, but I guess it is. If my calculus people tell me, like, I'm wrong, I'm sorry. This question was one that I wrote just to give us practice using max and mins, even though I don't know that they're going to ask you the range of a rational function. I don't think they will. I just threw that in. Okay, how would you do that on the TI? Can you see if I hold it at this angle? We're going to do second calc. We're going to find our minimum. We'll just do one of them. But, okay, so this is the maximum. The minimum is going to be somewhere over here. So I'm going to just type in left bound 2. Will that let me do it? Oh, it will. Okay. And then I can trace over to somewhere on the other side. If I can't tell that I'm headed back up again, then it's going to be a problem. And then I guess. And so did that give me the same value? It sure did. Can you read that? There you go. This video is kind of long, but you know what? I think I'm going to keep going. So stick around. Okay, so the next one. Let me come back here. I now am going to turn off this one and turn on. I already typed this in. Delete formula. Oh, no. F6. I wanted to select, not delete. There we go. Okay, and then over here, y equals, I'm going to turn this one off and turn this one on. And I don't need this. Clear. Or, well, okay, delete. We'll just turn it off. Okay, graph. So here are my graphs, and it says find all x-intercepts. So when it says find all x-intercepts, let's do G-solve root. Let's see what it comes up with. Okay, so we've got one here. What is this? X is approximately 0.32487. The other thing that I might want, and then do I have any more? Oh, I do. Okay, 1.4, can you see what I'm doing? I think you can. 1.4608. Do I have any more? I don't know. It's thinking. Yeah. Okay, well, so what we notice here is that this numerator was cubic, which is really gross. It was a really gross cubic, but these 3 were the zeros from that cubic. So if I had just typed in the cubic, then I could see where that cubic intersected. And so there's that. Oh, find the equation of all the asymptotes. Oh, this is going to be interesting. Okay, on this one, I don't really feel it. We'd have to, second calc, you'd have to find your zeros, and I think you have to tell it where to look. Yeah, you have to tell it where to look just like the other ones. Okay, so the Casio has a slight advantage. And I think I've shown you all the things on the TI that are unique to the TI, or, you know, so you just have to practice that sort of stuff. Okay, with this one, find the equation of all asymptotes. We know it's the same degree. So we have, for our horizontal, we're going to divide the leading coefficients, and we get 1/3. The other ones get a little grosser. So the other ones are based on let me see, let's exit out. I'm going to turn this one off, and I'm going to come down here and just type in, I should have typed this in ahead of time, but I forgot that I was going to need to, plus 8x squared minus 5x minus 11. Okay, so now I just have this graph on. This is the denominator. So wherever the denominator equals zero, I'm going to have a vertical asymptote. Or it could be a whole, but that doesn't factor, so it's not going to cancel out. So so then I have x is approximately equal to negative 2.7934. And then the next one, x is approximately equal to negative 1.0847. Did I write that right? No. For 1, because then there was a 0, the 7 rounded that. Okay, I'm sorry. And then we have another one. At x is approximately equal to 1.2108. And that was gross. But there we go. That's how we'd use our calculator. Find all values. Okay, so let me come out of here again. Let's turn this one off. Or I can delete it. I don't think I need it again. Well, hopefully I don't need it again. Select. I'm going to turn this back on. Draw that one. Okay, weird stuff is happening there. And if you notice, we had an asymptote somewhere in this area, and it doesn't look like an asymptote. So we could change our window to say, let's say 1 to 2 for our x values, and see if that helps us see what's happening. Okay, now you can see a little better that there is an asymptote there. Okay, let's go back, window, standard. Okay, so weird stuff is happening here, we just can't even tell. Find all values when f of x equals 3. So I may come in, gsolve, I can do an xcal, and I can say when y equals 3, what does x equal? Okay, and so x is approximately negative 4.2140, and I think I can go over and find that x is approximately negative 0.7546. And let's see if it finds that other one. It did! Fantastic! Good job, calculator. 1.218. We knew to look. I mean, you wouldn't have thought, oh, there's another one, but we knew that something weird was happening there. So I thought, well, I bet it's got another one. Let's try again. Do I have another one? No. Okay, so that's the biggest. Well, and that makes sense. Well, maybe it makes sense. Anyway, that's the reality of it. Okay, there's a local maximum between the two negative vertical asymptotes. Okay, so here's what I was talking about. I have these two negative vertical asymptotes right here and a positive one. So the positive one is somewhere near here. I'm not talking about that. I'm talking about these two negative ones over how it's approaching here and here. And so I want this maximum, gsolve max. Let's see if it finds that. And it did. Okay. Find its coordinates, negative 1.7233, comma, negative 6.4310. And I have answered that question. As I mentioned, this is beyond the scope of what AP would ask, but if you can do this, you can do anything. And then, let's see. Okay, coming back here, turning this one off, turning this one on. Okay. I see an asymptote and an asymptote, but it's kind of hard to tell. The Desmos does a better job with showing what these asymptotes look like. Okay, find all x-intercepts and show mathematically why there aren't any. Okay, what happens with this one, let's see, gsolve root. I think it's going to tell us none. Did you know that? Well, partly I wrote this problem. So, but what happens here is that I have a hole. This is going to look like, is how I like to say this, it's going to look like the graph y equals x minus 2 over x plus 3 times x minus 1. And with a hole when x equals 2, because that removed itself. 2, when I plug in 2, I get 0. So what happens is when I draw this, I have a hole at 2, but I can't tell. And I have an asymptote at 1. So you're seeing this asymptote at 1, and then there's a hole at 2. Watch this. If I do gsolve and I come over to ycal when x equals 2, it's going to tell me error, which we knew. Okay, so none x equals 2, or the point 2 comma 0 is a hole. It won't be an x-intercept because it's not defined there. Find the equation of all asymptotes. Okay, this was squared over cubic. Okay, so y equals 0 was an asymptote because it was bottom heavy. And then I have x equals -3 and x equals +1 that came from here. I could type those in my calculator, but I don't know that I feel like it. Okay, back to my window. There, oh, I don't know why I hit enter. Okay, G solve. We want to find all my x values where y equals, so we're going to do xcal -1. Or I could draw the line and find that intersection. Here's one of them. X is approximately -4.1926. Let's see if I can find another one. X is approximately 1.1926. Do I have another one? I don't think I do. Maybe I do, because there's an asymptote, but it seems to be, is that the same number? Okay, you know what? Let's check and see what's happening here in this. Let's go back to that window. Change this from, we had an asymptote at +1, so let's go from 0 to 2, just to see what's happening. Okay, and then we were trying to see when does it equal -1, so it's only one place. Okay, anyway, that makes me feel better. Window, standard, graph, there we go. And I want to know where f of x equals 2, so we can do g solve xcal when y equals 2. So here's one of them. Here, do we have another one? And I don't think I have another one, because we kind of zoomed in and it was going up on one side and down on the other. Okay, find f of 3, g solve, go over y cal, when f equals 3. So that was f of 3 is approximately equal to, can you read that? 0.081 through whatever, there's 4 decimals. All right, hopefully that was helpful. Practice with your calculator, practice, practice, practice. And yeah, like, subscribe, comment, all the things. Good luck.